So today is day 11 and today's question is maximum product subarray. So we are given array nums and we have to find contiguous subarray within an array containing at least one number which has the largest product, right? So statement is quite simple and algorithm is quite fun. So if we look at this array 2 3 minus 2 4, if you look at continuous subarrays, right? So first can be 2, so product is 2, then 2 3, the product is 6, then 2 3 minus 2, which will be negative, and this will also be negative, and all other except 4 will be negative, so that's why 6 is maximum. In this case, if you try to look at all the subarrays, then 0 is maximum, so that's why 0. Right, to solve this problem, it is similar to a problem. We will solve another problem to learn about this problem, and that problem is called maximum subarray. It is marked as easy. It is not as easy, but this is a popular question in interviews. So we will try to solve this question, and for this today's question in September challenge, we will try to use that knowledge because it is very similar, right? So what is maximum subarray? So in this case we have to find the subarray which has the largest product. But in this case where we are talking about maximum subarray, we have to find the contiguous subarray. It should contain at least one number which is largest sum and return its sum, right? So we have to just return the sum in this question, and in today's question we just have to return the product, so we don't have to return the array for now, right? So let's try to see how this question can be solved. So the algorithm is a DP solution, and I'll just talk about what that DP is, and then it's most part, like the biggest part of this question is to know that DP, or to come up with that DP. Implementation is not that difficult. So let's say these are the elements. Right, so suppose we are moving element by element, and what will be my DP? DPI will be subarray ending at, which means including ith, right? So including ith element. So subarray ending at including ith index with maximum sum, right? So this is DPI. So what is DPI? It is the subarray which will end at ith index, and it will have maximum sum of all the subarrays ending at ith index, right? So I know this DP suppose, and then I need to figure out DPI plus 1. So that's how we form DP here, DPI. So we will figure out how we can come up with DPI, right? So let's now assume somehow I know some till D, right? So DPI here is something, let's say X, so the value here is X. Now I need to find value at E. So what can be the value at E? So that is what we need to figure out. So if we think about it, so if a subarray is ending at E, then if it is ending at E, then where can it begin? So it can begin at E, it can begin at D, it can begin at C, it can begin at B, it can begin at A, right? Right. So if it begins at E itself, then the answer will be E. So basically we need to find max for all of these beginnings, right? If it begins at D, let that solution be, let's call it DE, similarly CE, right? So for all the beginnings we can check if somehow, so if we were doing brute force, then we will see that at all the beginnings we will check for all the beginnings what is the sum, and what is the maximum of all these values, like AE also will also be there, right? So but if you think about all of these possibilities, right, which are beginning before D, that means it already contain that subarray which is ending at D, right? So if you look at any subarray which is ending at E and starting before D, it will contain a subarray which is ending at D, right? So basically you can write this as, so d comma d, and then you can write c comma d. So where in brackets we are saying that where the subarray is starting and where the subarray is ending. That means this means e comma e, right? So similarly you can write, so it is starting at b, that means it goes from b to d and then d to e, right? Something like that. So that is the notation we are using here, command d. Right, so if you think of all of these and find, you have to find the maximum of them, then sum from d to e is constant. Then you only need to find which is the largest subarray ending at d, which is the largest. You have to find the subarray which is ending at d and it has maximum sum, right? And that is what exactly dpi is, and which is exactly what x is. So that now the question becomes very simple. So the answer can be either e or x. Right, so that is the trick we need to, that is the technique we will use to solve this question, which is if you are able to somehow compute dp ending till ith position at I plus 1th position, either you will be using this subarray and ending e to it, or you will be discarding this subarray and just using e, right? So that is the trick, and there can be a little bit more intuition which can go in understanding this, but I will skip this. You can just think that if we are not choosing e alone, that means adding e to the previous subarray is actually increasing its value. So something like that, you can think along these lines. But the dp, how it is derived, I just showed here. Like you can think about something like this, and then you come up with a assumption with this solution that either can dpi plus 1 can either be dpi or it can be e, right? So we will just check who is maximum among them, and then that will be the solution for this index. And what will be the overall solution? Any of these solutions, right? Max of these solutions. So if I know the maximum array ending at c is of size 3, but everywhere else it is, let's say, 1, or it will have to be 2 here then. So then basically we know that 3 is the solution overall. So we calculate for every position, and of all the positions, maximum will be the answer for whole subarray, right? So that becomes easy now. So now it's not very difficult to code. So let answer be so let's handle our corner case first. So is it given that it is not empty? So it is given it is not empty, so we will not put it. So what we can do is so is equal to also okay, so answer let it be equal to -1. Oh, negative elements can also be there, so minus infinity. All right, so let's make dp array size n, and let's fill it with 0. As we know that there will always be one element at least, then we can just do this, because we know that the first element will always be there. So what will be the solution ending at first element? It will actually be first element itself, because you need to have at least one element, right? So for first element, the dp0 will be num0. Now we can start. Okay, give me 1 second. Then we start from the first index, because we have already considered 0, then I is less than n, right? So what is the value, current value, or we can just call it current value, which is in our case was e. So that is current value is num_i. Then what will be the value of dpi? As we mentioned, dpi will be equal to math.max. It will be math.max current element or the previous value, dpi -1, return dot max, right? So all the dp values, you just take the max. So that's it. So that's why it's easier, this question. let's see if there is some corner case. TV. So we don't define it like this in JavaScript. So output is 4 and expected is 6. So where did we do it wrong? So that was like I was wrong. It is not one of x and e. It is actually one of e and x plus e. As we mentioned here that x is ending at d, or we also have to add e. So that is what I missed here. So we have to take care of that. That either it is the current element, or so basically current element have to be there because it is ending at current element, right? So that's what I missed earlier. So either it is current element or the array ending at previous element plus the current element. So we have to add current here. So let's see if this works. So for this one it is giving correct. Let me just submit it. So there seem to be some issue with, maybe you need to take care of integer overflow, I'm not sure, but for JavaScript this will work, so I will not worry about that. So let's just try to submit it. So this is accepted, right? So this solution is correct. So there is one more thing which you should notice to save memory, that we are only looking at the previous value of dp, and previous to that, for example, for I am not at all looking at other values of dp, right? So instead of making an array of dp, we can just have this num0, right? We can just have let previous dp value, right? Let previous dp value, right? And then you can just say here that previous dp value is equal to, but here answer will also be equal to, right? So now we are instead of looking at that whole array, we will be looking at only the previous value. So the previous value is for one array only, the dp will be the first element, and for all the other elements we can just do this, right? So you just think about it a little while, that the next value of dp will be the previous value plus something like that. And what will be the answer? It will be current value of answer. So we were doing this right earlier because we had all the values at once, but now we only have two values, right? Pre-dp and answer. So we compare them here, otherwise we will miss it. So we do this here and we do answer. Let me run it. Awesome. Very bad. Should be like that. So I made answer constant and then we can't reassign it. So this is correct. Let me submit it and see if it is giving correct answer. So this is also correct. So the technique we used is like, it's not a very major technique, but you can save space for db if you realize that we are only using the last element, right? So that is what we did. So how did we come up with the dp? We look at current element and see if we know the solution ending at previous element, then either the solution is current element only, or the solution will be current element plus the array ending at the last element. So that's it. So that is the dp. So try to solve this question first, because the code is also not very big, so it will not take much time. And if you understand this, it is actually a very popular interview question. And also it is sometimes this problem, like finding maximum subarray, comes as a sub problem for some more tough questions, right? So it's a good algorithm to know. If you practice it, it will be better if you just remember it instead of trying to come up with this dp on the spot, which is not very difficult, but it's better that you know this algorithm All right, so let's try to solve the today's problem now. So what is this? Now you have to find maximum product. The only thing here which changes, I tell you, suppose we are doing this, and suppose the answer till d I know was x, then what will be the answer here? So actually we can't say it will be x into e or e. Why? because this can be positive and then this can be negative, then it will decrease a lot. But so like if you think about this idea for a while, you need to think that if this was negative and this was also negative, then actually it will increase, right? So the idea in previous solution was also something like that, that if we are including E, then if you are including previous array and E, that means E should contribute positively, which means this should increase the answer, right? So that's only when we wanted to increase E, include E in the previous. Otherwise, E alone will be sufficient, right? So that is what we will do. So, but here we need to think of the case where E can contribute. So if E is negative, it can still contribute if this product was negative. But if E is positive, then it will only contribute if this was positive, right? For example, the previous solution, let's say it was -6 and the next element was 2, but 2 can contribute to, but 2 will not increase the positive solution at this index, but it will definitely increase the minus or negative solution at this index. Why we need to take care of negative solution? That is because if the next element is negative, then actually this negative and negative will become positive. So what we will do now, at every index we will store two values. One will be positive solution, let that solution be P, which will be the maximum product you can get ending at this location. Second one will be N, which will be minimum negative, which you can get at this location. What will be the solution at E then? As we mentioned in the previous one, we can either first we can include E alone, otherwise we can include PE, because let's say we don't know the sign of P and E, because you can solve it in general way, then NE and then 0. If you look at all these values, right, so if E is so if you take max of this, then you will get next P, right? So suppose this was P of I, right? So if you take max of these values, it will give you P of I plus 1. If you take min of these values, it will give you P of N of I min, I plus 1. Why? Because suppose, so you can like you can enumerate in your own time that if E was negative and P was positive, then PE will actually be min, right? And if they both were positive, then PE will be max, and if both were negative, then NE will be max, and if E was positive, then NE will be min, something like that, right? So if you iterate over all the cases, you will figure out that this is the solution. But where does E and 0 come in, right? So because we have to find the maximum product, and suppose this E is positive, right, and product till D is also positive, then the minimum negative product you can get till E will also be 0, because you can't go negative, right? Because if minimum negative product till D is, so yeah, so basically I think then till D it will have to be 0 again, so something like that. So you need to take care that if you are not able to make a negative product at a particular place, then you need to make it 0, right? For example, if you look at 2 and 3, till here you can't make anything negative, so for that we are having 0 here, right? So this is what we will try to do. So let's try to solve it, and I'll just keep it here so that we have it for reference. And you can do it in a DP way as well, like DP of positive and DP of negative, but as I mentioned in the earlier one, we just need to check the last value. See, we are just checking the last value, P is PI and N is NA, so we will just keep that value. So let N be nums length, and if N is equal to 1, then we return it, right? Because if there is only one element, then the product can be that only, and we are actually given that we have to contain at least one element. So done. Now let's start with the first element of DP, which you can assume to be DP0, but we will be using only one variable, which is max positive value. What is max positive value? If the first element is greater than 0, so you can just write this 0, 0. So if first element is 0, greater than 0, which is positive, then that will be the max positive till first element. And what will be min negative? It will be nums 0 and 0, right? So if you think about it, this will be the maximum positive and minimum negative value till first element. So how we define PI and NI was, what is the maximum positive product ending at this index, and N is what is the minimum negative product ending at this index, right? So it was like, to come up with this, it might not be very trivial if you are looking at this problem for the first time. That's why I explained that problem, maximum sum subarray, so that you can take some intuition there and put it to use here, right? So now we know this, and let answer will actually be equal to non-zero in the beginning. Now we just iterate over everyone. Right, so let x be, or current value be, we are using e as the name, so let's use e, which is the current element, which will be nums I. Then we go, then what is the value of, so current max pos will be equal to, as I mentioned, so the next maximum value will be maximum of all those, so we have to find max e, and then max pos into e, min neg into e, 0. That's it. And current min neg will be just math dot min of these, dot min. Right, so that's it. So what I mentioned here, you can do some other conditions as well, like if x is less than, if e is less than 0, max pos is greater than 0, then maybe you can come up with some if else, but I think this is cleaner. Then max pos will be current max pos and will be equal to, so I'm typing it wrong actually, so this will be min neg. Right, so this is how we create it till here. And what will the answer, like last time, it will be my dot max of answer comma dot max. Oh, I think it should only be max dot pos. Let me try this. I mean, I'm not sure what I submitted, but what I guess is, like, at any point max pos can only be the answer and neg will never be the answer, so we just need to check that. Otherwise we need to take maximum of these two and then compare it with answer, right? But I'm thinking that only one of them will do. Let me think about it. But we actually have to include at least one of the element, right? So if we have to include one of the element, then it can be 0 as well. And if the current answer is negative, both of them are 0, then max pos. I think it will be in max pos. Let's see. If it gives wrong answer, then we will find max of those two. We will find out, like, instead of yeah, I mean, like, generally you should try some test cases and see if you're wrong. But right now, just to save time, I will just try to submit it. So this is given correct for these two. Let me just submit it. If it gives wrong answer, we know. So this is correct. So I think that is it. So yeah, so that is what we did. We looked at the DP for like maximum sum subarray, and we tried to extend the DP by saying that next element can improve the answer if we consider positive and negative answers till the end, and negative answer is actually minimum negative, because when you multiply two negative numbers it becomes positive, so we can't exclude negative numbers, so something like that. So that is it for today. Hope this was helpful. And this question, which was maximum sum subarray, is actually a very important question for interview preparation, and in general it's a very good simple DP technique. So hope you remember it, and hope this was helpful. Thank you.